Okay. All right, here we go. Corey, you're 50. And that is. Okay. Now, I think, if I recall, we're ready for page 17, letter E. So here we go. We're back with the same thing. We got 10 juniors and 16 seniors, and we are picking 5. Letter E says no more than 2 seniors. So what does that mean? No more than 2 seniors.
0.
You can have 2 seniors.
1 senior.
And by the way, guys, if we're picking 5 and 2 of them are seniors, then we have 3 juniors, right? Or we could have 1 senior and 4 juniors, or we could have no seniors and 5 juniors. Would everybody agree that that's the setup for the problem? These ors mean we're going to be adding, right? So we're going to do 3 separate problems and add them all up. So here we go. What does 2 juniors, or excuse me, 2 seniors and 3 juniors look like? No, it's not 5C anything. How many seniors are there to pick from?
16 seats.
And I am picking 2. Times, how many juniors are there to pick from? And I am picking 3. So there's the first case. Now what does the second case look like? 16 C1. There are 16 seniors to choose from. I'm picking 1. Times 10 C4. Or, what's this one look like?
Just 10 C5.
10 C5. If you want to include, we talked about this yesterday, if you want to include 16 C0, you can, but you don't have to. Sometimes it makes it look more lined up if you do that, but you don't have to. You're not picking any seniors, all juniors. Okay? Now, is this a probability question?
Yes.
So the whole shebang is going to be divided by the total. How many total people? How many total people? 26. How many are you picking? 5. So your denominator is 26C5. Yep. Type in all the stuff on the top and hit equals. So type in everything on the top and hit equals. And anybody who whines and complains because it takes a long time to type it in, I invite you to go back to the olden days. I'll teach you how to do it by hand, which is the way I had to do it.
How would you do that?
How do you do that? How do you do that?
Did you have to like write a letter, put it into a pigeon, fly away somewhere
Oh,
else?
there are formulas associated with that. All right, I have no idea if I typed this in right. I got 0.2738. And if you do it with fractions, mine won't change. Yours might. Mine isn't changing it. So that's what I got. All right, one more of these and then we're going down to the candy problem.
Oh, I got it.
Okay. We're picking 5 people still. We want more juniors than seniors. Now, wait a minute. What does that mean if we want more juniors than seniors out of 5? That would mean we'd have to have either 3 juniors or 4 juniors or 5 juniors. Didn't we just do that?
Yeah.
Isn't that what this is? Yeah, so problem F is simply a rewording of problem E. Because if you want to have more you're picking 5. If you want to have more juniors, then you have to have 3, 4, or 5 juniors. And that's what I just did. 3, 4, or 5 juniors. So problem F is right here. Done. It's the same as E. E and F are the same. All right, I have 10 chocolates and 20 gumdrops. I'm gonna pick 2. Now this is the same as picking juniors and seniors, picking spades and clubs. The setup is exactly the same. I want no chocolates. What does that mean? If I don't want any chocolates, then I must be picking 2 gumdrops? What will that look like, picking 2 gumdrops? 20 C2 over 30 C2. Isn't that the probability? Why is it 20 C2? 20 gumdrops, pick 2. Why is it 30 C2? 30 total candies, pick 2. Right? So that should be easy to type in. Please don't try to cancel anything. Nothing cancels there. You gotta type it in.
38 over 87.
I got 0.4368, which is 38 over 87, if you do it fractionally. All right, what's the probability I will get 1 of each? So I'm picking 2 candies out of this box right here. What's the probability I will get 1 of each? Now, what does that mean, 1 of each? 1 chocolate and 1 gumdrop, right? So how do I pick a chocolate? 10C1. There's 10 chocolates, I'm picking 1. And I need a gumdrop. So what's that gonna be? 20C1. And what will my denominator be? 30C2. It's not changing. The denominator stays the same if I'm only picking 2 candies out of 30. All right, so let's see what we get here. .4598 or 40 over 87? That's the answer. I think. Anybody else get that?
I got it. I got it.
Thank you. At least 1 gumdrop. At least 1 gumdrop. What does that mean? I could have 1 gumdrop, or I could have 2 gumdrops. So I can have a gumdrop and a chocolate, or I could have 2 gumdrops. Is that right?
Yeah.
Now let's put our thinking caps on. What did we just do? What was this right here? What was this answer? That was 1 gumdrop and 1 chocolate. So this one is going to be 4087. So I already did that. And what was this one over here? No chocolates. So that was 2 Thumbs up.
So 38 over 87.
So that was 38 over 87. So my answer is 78 over 87, is that right?
Yeah.
And that actually reduces. What does 78 over 87 reduce to?
26
26 over 29.
26 over 29. Now, on these multiple part problems, sometimes you can use an answer to one part to help you with another part. So, remember how E and F on the problem above turned out to be exactly the same question? So if you're keeping your eyes and ears open, sometimes you can save yourself some time. Could I have set this problem up and worked it all out? Absolutely.
I would.
But I'd already done that,
Right.
right? All right, let's look on the back. We got some review problems. This is a lunch period, isn't it?
It's not. It is.
All right. Now, these review problems, and I'm only looking at the circled ones. We're only looking at the circled ones. These will be all mixed up. To win a prize in a competition, a door number in an apartment block is chosen at random from the numbers 1 to 150. Find the probability that the door number is a square. What do we mean by a square? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. What's 11 squared? 121, 121, 144. That would be it, right? How many of those are there? 12? So the probability of getting a square number will be 12 over 150, which reduces to something. Let's see, 6 goes into that twice, into that 25.
It's from the reading.
So in order to do that problem, I just made a list of all the squared numbers. There's a question similar to this on your test, where you just have to write out what are the options. All right, at least 100. At least 100. So in other words, we want the numbers 100, 101, and so on, all the way up to 150.
Well, there's only,
This always catches people. I want you to stop and think about this for a second, okay? Open up your minds. Think about this. We have potentially everything from 1 to 150. If I want 100 on, how many am I excluding? How many numbers am I leaving off? 99. I'm leaving off 99 numbers, right? So if I had 150 and I left off 99, how many are there? 51. There are 51. Another way to think about it is, if you started with 101 and got to 50, wouldn't that be 50? But you still have 100, so that is the 51st. Yeah, that's the 51st. This reduces to 17 over 50, I think. Divisible by 5. So what are those numbers? 5, 10, 15, oh my gosh, there's a lot of them. So one option we have is to write them all out and count them up. So if that's how you feel safe, that's how you feel like confident, then that's what you're gonna do. I'm not. I'm gonna say to myself, there's 150 numbers. every fifth one is a multiple of 5. So there must be
30 of them.
So that's 30 over 150, which is, oh, imagine that, 1/5. Does that make sense, that the probability of getting a multiple of 5 is 1 out of 5? It sure does. No more than 11. No more than 11. Now what does that mean?
Everything less than.
1 to 11? How many numbers are there 1 to 11? Count them on our fingers. How many numbers are there 1 to 11? No, there aren't 10. There's 11. Guys, stop it. Oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 of them.
I was just slow. I guess I am.
So 11 over 150 is the answer.
I started from 2.
Now, those of you that are like, I don't know what you're doing, I don't know what you're thinking, you are probably gonna be safer just to write them out. Write them out and count them up. It takes a little while, sometimes you really need to do that, but you need to do that, okay? Don't make random wild guesses that are crazy. Okay, number 4. A packet of seeds contains 65% green and 35% red. The probability that a green seed grows is 0.85, and then a red seed grows is 0.74. A seed is chosen at random from the packet. Calculate the probability that the seed grows. How are we going to set this up?
A tree branch.
Exactly. Now, remember, the question is always step 2. This is step 1. The question is always step 2. So step 2 is, it grows. Find the probability that it grows. What does that mean step 1 has to be? What's the other piece to the puzzle? Whether it grows or not, or what? Green or red, exactly. Green or red. The probability that it's green is 0.65. Now, then we're gonna grow or die, not grow. So a green seed grows at 0.85. And a red seed grows at 0.74. Now we want to find, we're doing A. A says we want the seed to grow. So isn't, or aren't these 2 branches the answer? So we're going to take our calculators and we're going to multiply 0.65 times 0.85 and 0.35 times 0.74. And then what are we going to do to get our final answer? Add those together. And the answer to A is 0.8115. Everybody in agreement?
Yeah.
Okay. Good job. Second part. Is green and grows. Now wait, I think we already have that answer.
Yes.
Is green and grows would be 0.5525?
Yes.
Oh, cross out C, it's too hard. Maybe not for you, but I don't want to take up time to do it. All right, we're gonna do this. 6 is our last one. The probability of B and C is 0.1. So I'm just going to go ahead and draw my Venn diagram. And where am I going to put the 0.1.
In the middle.
In the middle. This says I like bananas and carrots. There I am, right there. Bananas and carrots. Now, what does this say? This says I like bananas and I don't like carrots. Well, wait a minute. I like bananas, but not carrots. Where will I put that 0.4? Right here? Those are the bananas and not carrots. And then, the probability I like bananas, oh, I don't like bananas, excuse me, but I do like carrots. Oh, no, that's what I'm finding. I'm sorry, that's what I'm finding, okay. So do I have everything up here that I know? Okay, all right. What do you think, guys? Okay. This says I like carrots. Okay? So that would be this part right here, right? I'm gonna color in, that's the carrots only. Actually, that's all the carrots right there. All the carrots. Or, I don't like bananas. Okay, where am I if I don't like bananas? I'm all here. You agree with that? And I just put all that together because this is an OR problem. So what's the answer to the question? How much is shaded in? How much is not shaded in?
0.4.
0.4. So how much is shaded in? 0.6. Kids, you don't need to know what these sections are because you know the whole thing adds up to 1, right? 100? Yeah.
Yeah.
We should just take.
Okay, good job. Remember that tomorrow